Hello, hello. Seems to be working fine tonight. My goodness, he has gotten cold in Germany. It's no t-shirt tonight. We have 4 degrees Celsius this evening. It's probably getting even colder. So welcome everyone to our live stream tonight. I was not sure if I could make it, so the announcement was also very short notice. But I also wanted to test out a few things. For example, tonight we're gonna check out if we're gonna map the workshop camera to a button on my Stream Deck. Scene. Let's move it here. Workshop. So this can probably working. Yeah, that's the workshop camera. And then I think we can also add the studio camera. Let me copy paste. Let's see, studio mode. Okay, so we can copy paste stuff from, let's see, the B camera. I think this is good. A cam, B cam, overhead. This looks great. So I'm copying this over. And I'm copying this to my, this is, yeah, that looks nice. Okay, so let me test this out. Here we go. So we have our studio view and still can probably use, move myself up here. Should be good enough, I guess. So the idea is that last time I was going back and forth between the studio and the workshop, and tonight I also have stuff going on in the workshop. So I will definitely head over now because I need to get my printers busy again, just to remove everything, or I have to remove a couple of things. So first thing that I want to know from you, please let me know if you can hear me. That would be my first question, because now there's another room in between the studio and the workshop, and I just want to check if you can still hear my audio quite, say, undisturbed. So let me know if it works. Porphyrius, you say yes, we can. Okay, that's good. That's great. Computer. This RAM material. So this is face. You know, in the past, talking about video to show the project and how things come together. But really, this is how the parts look like. This is, for example, a top element that is, and pieces of these parts. So you need basically, if you want to print such a computer case, it's 6 pieces, 5 pieces are printed in the same color, and one is at least one of or at least material that light through, because they're and that sits in between the body part and the top element, and then you can have an LED strip in there. Actually, I have a computer running right here in the work. So start another band ring print here. Here in the corner, should see that. That's the Prusa Mini. That's still printing some of the hard disk mounts. And this one is gonna get busy doing the top grill, one more thing. And this one is actually the X1 Carbon has a clogged nozzle. I have to fix that probably tomorrow. SPO6 is printing the mainboard holders. So everything is. Oh, when you buy the printers, you keep cutting out. Okay, maybe then we have too much interference. Can you hear me now? Okay, now I'm talking. Yeah, probably that's the Rode microphone able to reach the receiver anymore. Okay, so it's interesting because the distance is actually it's not different. Actually, same distance if I'm in that corner towards the receiver is probably even shorter. But yeah, that can probably fix that at some point. Good. I'm going back to the studio. Just wanted to make sure that the printers are busy. One unfortunate thing is this temperature in this room was going so high tonight. So I had to open the windows again and make sure that the room cools down. We had, I think, 28 degrees in here, Celsius. That's probably too much. Also tells you exactly that. So if the room temperature is clogging, and that's what happened supposedly. So at some point, probably tomorrow, I will have to clog the printer. No time for that today, but yeah. Then we have another printer here right under the camera, which is the Creality K1C, and that should be printing a couple of things for another project that's still in the making. I just want to make sure that we are keeping this printer busy for at least the evening. So I'll show you more about this project probably next week when I have a couple more parts printed, because that's so many different 3D printed parts that I have to finish a couple of them now to show you the project. Otherwise, it doesn't really make sense. Okay, is it ready to print? Okay, where's my downloads? Here we go. Oh, it's too big for a printer. Can we? Okay, that part that I wanted to print has to actually be printed on the Bamboo Lab. That's okay. So we'll do that later once one of them is getting free. I'm getting back. So, first test successful, I would say, using this workshop camera. And also what changed, I think last week, I I started using or I upgraded the P1P with an AMS. I had that AMS already, but I printed a razor, so it's a little bit higher up above the frame. Then I added another P1S and another P1S. So now we have 4 Bambu Lab printers here. The SV06, the Creality, and the V3KE, and the how's it called? K1C. The K1C. Yeah. So now we have like 7 printers and a little Prusa. So 7 printers are printing for this project, which is paid by our customer, and 1 printer is the K1C, which is out of frame, which I'm using for a couple of other prints at the moment. And we are building a printer. If you remember last week we were making some good progress with this project here, the Voron 0. Actually not too bad in terms of how far we got. We already installed the motors and the belt drive, and everything seems to be moving nicely. The bed is also installed. No electronics yet, at least. Like there are some cables, of course, but there's no main board yet installed, and we're still missing the whole the extruder and the hot end and stuff. So we'll have to see where we are going today, how far we come. Yeah, we did tune the belts. Effectively, yes, we used a real instrument tuning software. That was a part of the recommendation, that you use an instrument tuning program like this, which tells you the frequency of the belt, and then you can basically tune it to 110 Hertz, which is the target, the best frequency or the recommended frequency to tune the belts for. Actually, I never thought about this, that this is actually a valid method to do this, but it works. It really works, and it seems to be quite stiff, but probably just not too stiff. Like, it's just probably what they need. Now today, I need to double check actually what we need to do next, because when we left off, we were just finished with the belt installation, and I need to see, and we installed the hot end, the heated bed. So let me show you where we left off. So this was the place. Essentially, we installed the heated bed. We did it in a different order, a little bit slightly different, because my version of the magnetic pad that's going to be going on top doesn't have holes, so we have to install the screws, the tightening screws first, the bed screws. So we did it in a slightly different order. We installed basically the build plate, and then with all of the screws and the tightening knobs. This was already prepared. So with the new kit version, you get the heating pad is already pre-installed, the cables and the sensors and stuff, so we don't have to do that all over. And we also installed the thermal sensor, and that's already in place. And then we installed it to, in our case, it's the Kirigami bed mount, so it's not built from extrusions. The mount that we are using is made from aluminium, so it's CNC machined aluminium. That's the part underneath the bed that's holding everything. It's a little more lightweight. And then yeah, we have for the wires, we didn't push the wires anywhere yet, because that's also different in this version here. There is no like distinct hole in the Kirigami for running the wires. It's done a little bit different, because we have the Wago clips to connect the cables. and that's not mentioned here. So it's all done a little bit differently for the Kirigami, and then we need, yeah, we're next installing the cable chain. I think what we should probably do is go back to this page where we had skipped the installation of the magnetic pad. I'd say since we have everything in place, we can just do it and clean this first with alcohol, and then we should just put it on. That's basically risk-free now because we have all the screws installed, so it should be good and ready. How is everyone doing? I see, didn't say hello to everyone yet. Let me check who's here actually tonight. Not so many people yet. Porphyrius, hello, hello, good evening. We have Xylion there, another often seen guest here. Then we have GeForces, welcome back. DIY Inventions, welcome, welcome. Welcome to Algeria. Nice to have you here. I think you're here. I didn't see you here yet. Great, great. And who else? I think that's all for now. That's at least the people who have put messages into the chat. Everyone else who's already here, welcome, welcome also. And oh my goodness, these bottles. I hate it. It's a kid safety. So, cleaning the surface first. So we get our little sticker installed, magnetic sticker. And again, you can see it's so tiny. Oh my goodness. What's the real size, by the way? I don't know. I think I wanted to measure this. I think it's 120 or something. Yeah, 120. So it's tiny. I'm curious what we can print on this. Probably can print benchies. Kitty proof. Yeah, your wife can't. Your kid can open it, but your wife can't. That's awesome. That's awesome. That's what it's supposed to do, right? Protect it from your wife. So at least that's a good reason why she needs your help. Okay, so let's put the sticker on. Since this is a very small sticker, this is quite easy to do compared to maybe others. I just want to leave a little gap here. It's not exactly the size, a little smaller. So I want to keep a little bit of a distance. That's, yeah, I think that's good. That's good. So don't push it too much. There's no bubbles under these here. So before using this, we should leave it a little bit because the glue needs to settle. Oh my goodness, where's this dirt coming from? Some cat hair. Oh my goodness. Oh my God. We have 2 cats, and that's always get cat hairs everywhere. Good. So that is installed. That's ready. Is it centered? Yeah, it's almost perfect. It's not perfectly centered, but it's good enough. Then next, back to the manual. Let's back to the instructions. What do we do next? We probably should always come back also to this manual here that has explicitly some parts that we need to do differently. So we are on page 152. Yeah, I think we did that. We did the lock nuts for the bed screws. The wiring is done on 152. We're not doing this like this, as I said. We are going to use the Kirigami. Where is it? There's a specific Kirigami bed wiring guide. Let me see. I think this is. It should be this page. Quite slow tonight. What's going on? Yeah, that is exactly the same page. So we should be good. We just go down to the wiring instructions. Here we go. It's not yet. Why is it not loading the images, my friend? So for that, we need to turn this whole thing upside down. And I'm not sure if you will be able to see everything. Why is it not loading? It's very slow tonight. That's unfortunate. Get rid of the cats. Yeah, I think this is this problem is gonna solve it on its own at some point. So, what's happening? Why is this not loading? Why is it so slow? It's unbelievable. At least we're not dropping frames or something. We're still doing good. And frame rate is fine. One thing that I was stumbling upon in the last couple of weeks using the OBS is that at some point the frame rate started to, like, not this, like the actual frame rate for Twitch or YouTube. So there wasn't an error, but my local frame rate, so to say, like locally, was definitely staggering. So it was going down, and for no reason. I have no idea what happened. And then at some point it's going back to normal. So it's very weird. What is happening? Why is this page not loading? Why is this not loading? So now I have the feeling that this is not really very smooth. It's kind of stuttering, right? It's not really, like, it's not 25 frames per second. If you ask me, it's not perfect. I don't know. Maybe it's just my impression here. And maybe it's actually good. So the page is, I don't know what's going on. Is this the specific page, or is it anything else? I don't know. Our other page, no, this is loading fine, right? This is loading super fast. LDO motion, what is going on your website? We need this to work tonight. Fuck. My goodness. It's so slow. They clearly have an issue. If other pages are loading fine, right? Honestly, I have no idea. LinkedIn, boom. No problem here. No, it's definitely their page. Definitely their own page here, which has an issue. Unfortunate. We have to figure it out ourselves now. I guess we are on our own. So we have the wiring guide. We don't have it. Unfortunate. Kirigami bed wiring for the heater, thermistor, and NeoPixel. So let's just leave it as it is for now. Let's skip this for now and then skip on to the next pages. We're gonna come back as soon as you can see this page. Now it's loading. What is here? Are you kidding me? Okay, so but the pictures didn't load. Why? Inserted 2 heat pad extension cables into each of the Vagos. Heat pad extension cables, black with red ferrules on the picture. Yeah, not seeing the picture. My goodness. Okay, we're gonna take out the wires. There's 2 different bags with wires for this printer. Maybe it's going to continue loading to a point where we can actually see something. Power cable, heat pad extension cable. That's what we are looking for. Insert the 2 heat pad extension cables, black with red. Black with red. So we have a couple of different cables here in this bag. We have 24 in. I think that's a cable for the power supply. We have a bed heat cable with black bed heater cable. That's great. So we are installing that into the Wago. Problem for you will be you won't be able to see it exactly because I cannot. If I turn it in this direction, you can probably see where I'm doing this. There's 2 Wago clips here underneath the Kirigami bed mount. Not sure. Do we have a? Is it? Yeah, it's auto ISO, but it's not. There's not enough light here. It's too dark. So let's have some additional. Let's have some additional light here. It's also better for myself, so I see more. Better, I guess so. So we have the Wago clips here. We'll use the cables that come and install them. Barely can see this, but if one cable goes in, clip, and second goes in, and we're done. Super easy to do. That's why I like these Wago clips a lot. And put the JHT connector on the thermistor extension cable into either connection on the joiner PCB. Okay, we have a little extender PCB here on the Kirigami. There should be an extension cable. It's probably not. There's one connector at least on one end. And we are just plugging that in. And then we have the same type of plug here on the thermistor, which goes into the others. Put the JHT connector from the heatpad thermistor extension cable into the remaining open connector on the joiner PCB, and we have one cable from the actual sensor that goes into the second connector. Where is the, which orientation has it? Okay, facing up. So let's push that in. So that's in. Still, yeah, it's basically free here. Then we have the 2 cables coming from the heat pad. We also need to push them here into the Wagos. 1 and number 2. And this looks good. We probably need some, I don't know if we need to fix those cables somehow. Maybe. For now, I think for testing out stuff, it's good. It's good enough. We want to definitely do some testing first when we connect the stuff to the main board and the power supply without mounting everything so much yet. Are the Wagos good enough for the current that's used to the heaters? Should be. First of all, it's a very small heat pad, and they are used for 220 volts. So it should technically be fine. Last but not least, we have the NeoPixel cable. The NeoPixel cable is also somewhere here. So I think it's this picobellical. Now the NeoPixel cable is actually somewhere else. That was here. Let's figure this out. So we'll also need that cable chain in one of the next steps. So this is the NeoPixel cable, my friends. I have one end where we still probably have to figure out which pin goes to which target pin on the mainboard. We have 3 available cables here. Probably need to push them into this JST connector once we figure out how this is connected on the mainboard side. But for the front PCB, and I was wondering last time actually why they didn't mention this earlier in the manual. We can try to connect it now to the front PCB. I'm not sure if I can do it. Not with pliers, it's probably possible. Yeah, it should be doable. But still, it's a hard to reach section. I think in the manual they should have mentioned that we need to do it earlier. And either I missed that or it was because of the different, maybe because of the different manuals and the different changes in the manuals and whatnot. But yeah, it definitely still works. So we can push that in. Now we have this front LED cable connector done. Now I'm wondering, where do we fix? It mentions here that we should use zip ties to fix cables on the side. We should probably do this. Figure out which parts could collide, which parts could actually be touching the frame accidentally. We don't want that, of course. There is holes here. Some places have some holes where we could use zip ties. Let's figure this out. I think we definitely want to fix the LED cables here to the side frame. On the inside there is a hole for a zip tie. We can figure out how we can probably push a zip tie through. I think this is possible. Didn't they include such, or do I have to use my own? I am not sure. I'm not so sure if zip ties is part of the kit. Probably yes. Question as always is, where did they, which bag? None of these, at least I'm sure. Probably somewhere else here in this box. Yeah, there's a huge pack. Pretty huge pack of zip ties here. Where's Tutankhamun? I don't know. I'm not sure if he's coming, probably didn't see the notification. So let's at least do one zip tie here. Let me try. I'm not sure if I can do it. It's not easy. Now, since everything is already, we probably, there is a chance that we need to remove the the heat pad one more time, or the hot bed or a heat bed. It's, yeah, might be. Let me try to do it from below. So we go in from below, I'm going to come out here. I'm going to push it back into the second hole, and then maybe we can connect it again. I think this could work. So yeah, we have a little loop here. Now we can use the loop and close it. You can't see that, but I show it to you. So our LED cable is, this is where I'm fixing it now. I'm basically having the LED cable, these 3 wires here, running it on the side of this extrusion. One zip tie is in place. I think we can also do a second one here at the end. I'm still unsure if this is the right thing to do, because I have no idea where they are running the cables for now. So we have to figure out how the whole cable tree basically will run, on which side, and where is my, I think probably the other side, and then how to run it all through this cable chain. The cable chain will definitely be installed now. So we have to figure out how we do all of the cables in there. Where's my, yeah, this is, let's close this. Cable chain is here. So this will definitely be installed, but it's on the other side. It's on this side. And how it works is we have that coming from below, and then it goes up to the frame. It ends up here, and when the Z-axis moves down, it will collapse to the inside. So that's how it will work. So basically, will collapse like this, right? So this is how it's going down. Now the question of the questions is: do we need? This is the right length, or because there's 2 more elements that we could use. What do they say? Is there anything mentioned in our manual? Let's come back to this. So we have end link. What end link? The end piece of the chain was attached in an earlier step. That's right. If you swap them by accident, put the printer on its side, and you can easily swap them back. I think that's good. We did this the right way. My question would rather be, the exact number of chain links depends on the size and type of chain you purchased. There's nothing mentioned here, so it means you can probably just keep it as it is, because that was what the kit was, and I mean, we can at least start at the bottom. Can we start at the bottom? Maybe we should not start at the bottom. Bring down the bed a little bit. So let's figure out if this is long enough. Clipping it in here. Come on. Can you please clip in place? Okay, so I will just clip it in for now. If we figure, I think it's good enough. We can hold it in place. So this is the length. Can we go all the way up? Yes, that works. So it's definitely long enough, and it's not too, it's also not too long and not too short. Looks like it's good. So it was the right length. And we can just connect the last piece here. Just need to open it a bit. Interesting enough, this one doesn't have angled end pieces, so it's not easy to push it on. A bit harder. Let's use the little screwdriver. Come on. Definitely don't want to break it. Oh, damn it. Why are you not going over these two end pieces? That's unfortunate. The other end was actually easier to do because these pieces here were a little bit angled, the end pieces, so you could just push it over. Now this one is completely straight, so you have to open the link on each side, and we cannot push it over if we don't do it on both sides. It's definitely not possible. Why? We're making this so hard. We need something super flat to help out, and pliers maybe, and we don't want to break it. So let's see if this helps. The problem here is that we already have the bottom plate or the bottom cover installed, but that's as per the manual. That's correct. That also means we cannot easily reach anything from below. Why is it not working? I need a third hand for this, honestly. I need a third hand. Okay, I think I might have a chance now. Problem is that I don't want to break it. Don't want to push this too far out. So now it's working. Let's test it out. We're going all the way down. This works until we hit the end stop. Yeah, okay. Going back up. So I'm probably gonna leave it here so we can now fiddle in the cables. Yeah, filing an angle, maybe, but I think it's not necessary. Does this printer have a touch screen? No, it doesn't. It could theoretically get a touch screen. We can install anything. The thing that is supposed to be installed is this little screen here. That's the V0 screen with a turning knob. That's basically a miniature version of what you probably know, the good old 128/64, and not exactly 128/64, but it's something similar. It's smaller, of course. And you can also use a TFT35 touch screen. Now, my problem with the TFT35 is I have installed this on the V100, if you remember. The problem was that it is, I don't know, it had all kinds of issues with ghost touching. I don't know. It really didn't work so well. And I'm thinking now installing the TFT5 on the V100 is probably overkill. It's such a big screen. But yeah, maybe we'll find an intermediate thing that's maybe just another touch screen that works a little bit better. I don't like the SPI version of the touch screen. Maybe there's an HDMI 3.5-inch screen or something. Yeah, major overkill. I have the TFT7 here. It's huge. It's definitely, it's crazy. Right, that's a TFT7. that's definitely overkill. Right, it's really big. So more something for a huge printer. That's bigger than the print plate. It is bigger than the print plate. Okay. Is there a picture of the whole cable chain that you can count? No, but I think counting, I mean, we can, I think we figured out that the length is good, because two conditions: it needs to be going completely up without touching the upper end of the frame, so that is true. It also, when going down completely, it should not protrude out, which is also true, so I think it's good. How are we now running the cables is my question. Are we already doing that actually? I think not, right? Did we talk about that? There's no word about the cable. Oh, here we go. There. There's one little sentence here. Guide the heater and thermistor wires through the cable chain. That's mentioned here. So this is, yeah, we need to be very careful not to miss that. We want to guide the cables through. Let me think. Yeah, we're gonna take them from that side of the frame. We need to first have them on the right side. Now I have the problem that this end here, that's probably why they didn't install the plugs yet, because having those JST plugs on already would mean we could probably not run the cables through the cable chain. I'm also wondering, we probably want to run the cables through this part here. This is a guide, a cable guide. So we should definitely use it. I mean, otherwise it doesn't make sense to have that. So we're gonna run the cables. How do we do this? From the front. Oh my goodness, don't fiddle in here. Okay, so we use the cable guide. Hopefully I'm doing this in the right way. So cable guide should hold the cables in place. Is that correct? Hope so. Is there also some way to attach the cables? I'm not sure if we shouldn't just remove the heated surface. Maybe we should. Maybe we should. It's just not convenient to do this. I'm pretty sure that there is holes for zip ties in this little printed part here. Pretty sure about that. Is there? Or is it just cable pressing in and then that's it? So let's do the second one. The heat pad cables. Okay, so not too happy about this yet. We should probably figure out if there's any pictures from LDO, how they actually want to run the cables in the cable guide. I'm not sure if they have that. So there is definitely, if you look at this part from top, there is a wire guard. The wire guard itself doesn't have, it seems that it doesn't have any zip tie holes, so it's, where's this piece? Where is this piece? The print overview, where is it? Here. So this is the, come on, show it to me. Oh, come on. This page is so unreliable, honestly. Okay, can you show this picture now? So this is the wire guard and the wire guide, and it's running in one of the corners, like in this corner that's facing towards the cable chain. That's where it's installed. Also these bed spacers, I have no idea why they have mentioned this here, because there was nothing in the manual about using them. How to use them, I have no idea, honestly. Some very useful bed spacers. So what to use it for? Definitely not mentioned anywhere what they are supposed to do, honestly. You need to print 3, yeah? And then nobody tells me what to do with it. Okay, so coming back to the cable installation, that's how the whole thing looks like now. So we have a lot of cables are like currently underneath in this hole here. We have all kinds of cables coming to this point here. I think we need to cut the LED zip tie that's actually on this side. It's wrong. We can also run the cable directly through this. But the bigger question is actually like how to get the cables cleanly around this corner here. This is a pretty sharp corner into this cable guide and then into the cable chain. I think this is the most crucial question. For me, it looks like better. It would be better to not have this installed. We could try it, but it would be easier if there wasn't, if the heated bed wasn't there. You know what? I'm gonna take it off. Gonna take it off for now. Just gonna take care of the wires, and then we're gonna install it. That should be in a different order, honestly. It should be different in the manual. There should be first install the main cables that go to the cable chain, then install the heat bed. Honestly, that makes so much more sense to me, because it's now so tedious to do this. I mean, so unnecessarily difficult. It's really pointless. So let's get this off. We're gonna reattach it later. I mean, we have the Vago clips for that, right? So we have everything, easy connections. We can just go back anytime and connect this whole thing easily to the Vago clips. So now you see what I mean. It's super easy now to install the cables. Much easier. Much, much easier. So let's get all of the cables up here. So now they are coming around this corner. We're gonna push them through the wire guide. You see, so much easier. This is the wrong side. We don't need the zip tie here. We actually should have it on the other side. We don't want that cable on this side of the frame. We want it on directly straight through here. So the only question left now is, should we use some zip ties? Probably we should have one right here. And that's so much cleaner now. Yeah, I think that the guide is a little bit... Anyways, already confusing because it is already confusing due to you have to jump back and forth between the original Voron guide and the LDO version of the Voron guide, and you're always jumping between these different guides. So, and now we have these kind of things where clearly I would suggest a different order of things. It's just simple. So this looks very clean. It's not so much under stress. We'll probably want to have it a little bit relaxed here. So cable comes from the front into this guide. Now we are running it through the chain. Also, again, the question whether we want to do this all in one or we do it one by one. They have all have different length anyway, so it's probably easier now to start with the longest. See where we are coming out. And to make this easier, I probably also want to use some tape here, because we have now, for example, we have these 3 connectors here and they are very sharp edged and it's probably not easy to push this through. I would rather use some kind of tape. Again, where did I put the tape last time? Probably put it back into the workshop. We need some isolation tape. Most likely that will do it. Do I have it here? No. Now let's head over to the workshop and quickly check everything's going nicely, and then also get some tape. Great. So, what do we need? Isolation tape is... There must be some isolation tape here. Yeah, that will do. So, the nozzle clogging on the X1. That's unfortunate. So, insulation tape, yeah, this is essentially this tape that you can just rip off. And then it doesn't stick so much, and that's good because we don't want it to stick so crazy. I just want to have enough stickiness, but easily removable later. So wrap it around the... Just want to wrap it around this end here. Just 2 times or something should be good. Okay, so let's try it. Make it a nice end. It's a little bit round. So pushing that through, let's see how that works. Can we guide it through here. Might be. And again, I think there is also, like there's more complicated ways how to do this, and easier ways how to do this. If I'm honest with you, you can probably do this, the easiest way to do this, probably if you have the cable chain detached, right? So if I were to like make a recommendation to LDO, is maybe do this whole thing even before the whole chain attachment, blah, blah, blah. And I don't know if this is possible. It's still working, right? We can just push the stuff through. It's need a little screwdriver to help. There we go. So we have one end. We have one end that is done. And it will come out at the bottom of the printer. And there is a little, in this lower panel here, there's a little gap here where the cable will be coming out, right? So it's going to be easy to pull it under the printer, so to say, underneath the printer frame. And now we need to push the rest in. Yeah, another question, of course, for me, when we have all this done, all of the cables are nicely in this part here, and it runs through the cable chain. Do we have to fix it with using a zip tie, as there is no holes for that here, right? So there's no additional place to fix the cable to the end of. It's pretty loose. There's nothing holding it. So I'm wondering, just reusing tape maybe? There's not anything that sticks out to me that where I would say I would fix the cables now, or I would at least have something. Nothing. So number 2 is this pair, which is the bed heater. So let's push that through. Probably using a little bit less tape because it's getting harder, obviously, to push stuff through. So do that again. Gonna come out here. We don't need to reroute it back. Just pushing that with the screwdriver, so it runs around this corner here and then back down. So once we are around the corner, it's easier. But it's also like, of course, it's getting harder and harder. The more cables are in this chain already, the more friction there's going to be. So let's see. Can we keep it inside? So it's trying to escape to some extent. Okay, I think we're good. We're going down. We're coming out here. And number 2 is done. There's not much wire left actually at the lower end, so we need to have enough to go around this corner and up. The electronics is going to be around here. This is where the main board's going to sit. There's the back panel. So yeah, I think we should have roughly enough cable left to connect it. It's still should be fine. And this is the last pair, and that's actually very thick. I'm not sure. Maybe just do a little bit of tape. Just realizing maybe I should have done this one, not the first one, actually. But that's how it is. I think we can still do it. Still do it. Okay, pushing this We can also separate in the worst case, we can separate this and run the two individually. Might be what we have to do. I'm not sure. Is this possible? Oh, yeah. Even if there would not be the other cables, I think it's not possible to have them go together. So we should probably separate them. As much as I like this little sticker here with the labeling, I'm also convinced that, I mean, we can try to, yeah, we can try it like this so they are a little bit separate, or you can also push the end here in. So we have more like an arrow shape. Now fix it with tape. We could try it like this. Let's see if that works. But it's rather not so flexible anymore. So the question is, can we get it around the corner now? So we might have to pull it out completely and then push it back. Yeah, that might be necessary. But we can do it. It's still working. Still working. So we just push it down now. Straight through the tunnel. I think this is working. And we've done it. We've done it. Okay, so yeah, again, cables are not really fixed anywhere here, so they can theoretically move up and down. Maybe we'll find something in the manual about this, but I'm not so sure. Maybe just using tape to fix it a little bit better. This doesn't move so much. Okay. That's great. What next? What next? We have been running the cables. I don't want to put the hot bed, heated bed on just yet. Just double checking that we're not forgetting anything before we are reassembling the heated bed. So we guided the cables, blah, blah, blah. That's good. Mind the gap. Yes, the chain must not extend past the top. Yeah, that's good. It doesn't. No, we're going for the print head. So I guess we're good. I guess we can just go and reattach everything regarding the heated bed. I'm thinking about whether we should probably just also fix the cables here with another loop. So we have a nice loop that goes around here. Let me do that. Push it here so we can. It will force it down. It will make sure that the zip tie is going to make sure that the cables are not going to protrude into the zone where we have the heated pad. And it's making this nice loop here. And everything stays where it should stay. Good. How are you doing? Yeah, Bob Sima, welcome back. We are continuing on the Voron build, with the Voron build. We are almost done with the electronic, with the cable wiring for the heated bed. Routing, more precisely, cable routing. And we're putting the heated bed back on. So we want to do this carefully, then we're not losing the screws here, the tightening springs. So let's push the cables down and we can start aligning stuff. So we are hitting the right places. So starting with one of the screws. One. So can't get away already. Second. And number 3. Honestly, that was easier than I expected. But yeah, that speaks for this assembly. Let's check out the cables. Are they working? Yeah, it seems to be nice. It can move freely, so we are reattaching the heat pad cables to the Vago clips. And then we're probably thinking about, do we need additional zip ties or are we just fine here? I think when there's something sticking out to the bottom like this, it's good. That's okay, because it can not hit anything critical. There's nothing that we need to protect or something. The sensor cable, we need to plug that in up here. That's a little tricky. Can use the pliers. Should use the pliers probably. It's not the easiest to do. Come on. Can we please push this in? Come on. Get in. That's a little harder. It's a little bit under tension now. Why? Yeah, because of our, I think we should have it going through the middle. We have a little more room. Cable is not so much under tension then. Come on. Just want to plug it in, right? Why is it so difficult? Is this the wrong orientation? Oh yeah. Not only was it too short, but it's also the orientation was wrong. Now we're good. So there's the cables are protruding out a little bit to the bottom, but it's not an issue. We can run down the bed to the end stop. We're probably not going to hit anything. No, we're not even touching the bottom plate with the cable, so nothing to be worried about. So let's keep this, actually let's keep it down, because we want to do the hot end assembly now. Probably one of the most exciting parts of this build. So let's not forget about the connectors later. We need them. We still need to figure out the wiring of the RGB LEDs. how to connect that to the main board, but that's probably also, hopefully that's in the manual, that we're not missing out on that. Great, great, great. What's next? So we did all of this, we reassembled. So Bobsima, yeah, it's a nice build. The frame is made from these 1515 extrusions actually. The printer itself is quite small, you can imagine. The whole print bed is not more than 120 millimeters in each direction, the build volume. And the kit is from LDO, so it's an LDO Voron 0.2r1-S1. Complicated name, but it's the latest version of this small printer, the smallest printer from LDO. Supposedly it's a quite fast printer, but we'll see, right? We'll reach the point hopefully very soon where we can connect the electronics and the power supply and stuff, so we can test the printer. There's lots more to do. In the end, you want to attach all of the panels. There's a full enclosure on this printer, so there's plexiglass panels for the whole thing, so you can theoretically print also ABS. And there's a top hat, which is basically a top cover that you can open with a what's it called? Yeah, forgot the name. I think the way how it's attached, because you can just open it up, and I'm not even sure if they have magnets on there, but it is a cover, of course. But I think, how is it called? Hinges. Yeah, hinges are like on the top hat and the hinges on the front door, and but that's can wait. Basically, we can do that at the very end because it's not changing the printer so much in a way that it's functional perspective. We can, as soon as we have, theoretically, as soon as we have the print head attached, we could just wire up the cables without attaching anything to the frame, without attaching the main board or the rest, the power supply, anything. We could just attach cables and install the software and just test the printer. Actually, that's what I wanted to do that as soon as possible, to figure out if the mechanics work, because if we have to detach stuff and disassemble anything because we made a mistake or something, it's probably easier if we didn't yet install a lot of the panels yet, and a lot of the mounts for the power supply and stuff. I probably can just do that a little bit earlier to figure out if it works. Great. That was it about that. We're gonna do the print head now. We also need a lot of threaded inserts. Let me figure this out. I will show you what we have here in terms of the printed elements. We have a lot of nicely looking red ABS parts. That's what I printed. So that's essentially all the parts for the print head. That's the Revo mount, backplate. That's where the clockwork mechanics are. And this is the main part, of course, which everyone recognizes here visually, easily. And so we have to do kind of probably around 5 thread inserts on this according to the guide. Let's see what we have to do. So we have the main part, which requires 3 threaded inserts. We have this little hinge here. What is it? Shuttle. Yeah, that's a shuttle. Stupid standoffs. I think the standoffs is something I need to triple check. I think we have metal standoffs instead of printed standoffs. I am actually sure about that. It's mentioned here somewhere. 157, yes, 157. Heat insert for printed spacer are not required since the kit includes aluminum spacers. We need to find them. That's the thing. I remember that I have seen them, but I have forgotten where they have been. Honestly, what is this? So let me find those spacers now. They should be. What is this? Yeah, there's a couple of unopened bags yet. Toolhead in motion. Maybe it's here. We need the Revo hot end for sure. We need fans for sure. So a couple of things that we definitely will need now. So power supply not yet. So let's take a look. Come on, switch it. So some fans will be needed. A Revo hot end, and I guess we will find, this is the Bondtech kit, the Bondtech BMG, couple of screws, and I hope that we also have the spacers here. Not sure. Bearings. So I think this is all for the printhead for sure, but no spacers. So question of the question is once again, there's dozens of screw bags, and in one of them we'll probably find those spacers. Pretty sure. You just have to find the right bag. Or it is in one of the others still. And we just didn't see it yet. It is, some parts are labeled. Here we go. Look at this. Here we go with aluminum knurled standoffs. Okay, let's do this. It can get, it definitely can get confusing at some point. If you're not taking care of the different bags, putting them back into their original boxes, which I didn't. Okay, let's go back to the manual and see where we have to do heated inserts. We have these standoffs, that's for sure. So we don't need to do anything printed here. And we need to do a couple of inserts. Let's check how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's do the threaded inserts first on my working station here. So let's see, we're going to start with the main part here with this, the front part. I need a heat inset camera now too. I'm not sure. We could try. Let's see if we can use allow. Yes. Not sure if we can override the current connection. I have the workshop camera on. That's one connection with Epoch Cam, so Elgato. But I cannot use a second, it seems that I cannot use a second connection. It's not working. Okay. So that's unfortunate. Probably I need to use a USB wired camera for this purpose. Do we have something that we can use quickly? That's a good question. Do we have a quick way to connect my... we have one little camera here, actually. We have a little webcam here. We can try to use the webcam. We can actually place that very close. The only thing that's left is we need a long USB extension cable now to connect it to the streaming PC. Now we can figure that out. I think it's absolutely doable. We have here we have long cables, very long, very long extensions. So guess there's something that we can do about this. So let's see. We have the camera. It's a little messy over here, but it's a temporary thing. We can maybe we can actually make that a permanent solution once we have figured which port. Let's try this one. Let's try this port, and let's create another scene. So switching to studio mode, I'm creating another scene which is called the heated. Or let's call it. Let's call it which camera is it? It's going to be our back or date. Heat set camera. I don't care. I always rename it. So we need one scene for that camera, which is the jet. Twitch overlays, and we need a camera source, which is going to be webcam. It's the Microsoft webcam, and that's a, hopefully it's available, Microsoft Live Cam HD 3000. Is it working? I have no idea. Configure the video, custom resolution, 25. Let's see if is it working? No. Seems that it's not doing anything. There's no image from the camera coming, unfortunately. Why? I have no idea. Yeah, there's an app. We can use that camera. You're right. We can test if that works. No. So how do we switch cameras? How do we switch it? How do we switch cameras? Camera settings, video settings, camera settings. Oh my goodness. Video settings, related settings, blah, 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 blah. I have no idea. Why am I not able to switch the cameras? That's the wrong camera, my friend. It's just a camera that I'm not using at the moment. Why is it not working? Oh, can't start your camera. Okay, close. Oh, it's not working. So probably the wrong, let's connect it to a different port from the PC. Maybe that's the reason. Maybe it's just, it needs a USB 3 port or something. So let's use the USB 3 port. Okay, let's try one more time. Is it working? Now it's not even showing. Or maybe the camera is broken. I have no idea. It's not even turning on now. My friend, what is going on? So one last idea, one last try. Not using it on the USB hub. We're going to use it on one of the back ports on the computer directly. One of the let's find one. So let's try this one. There's one free port. Should do it. That doesn't work. I have no idea. Let's figure this out. It's probably another one now. Oh, come on. Microsoft Live Cam. Do something. No, it's not working. It's not working. My goodness. So yeah, I tried the USB 3 port. It's not showing up. So let's try one more time. Just left the dialog completely and it is showing up as a camera. Now we see something. Now we're getting there. Okay, let me bring this up for you in a second. I'm ready. It's a weird resolution. I don't know if it supports 16:9. Yes, it does. Okay. So, where is it? Transform, reset. And now, come on. Is it working? Ha! What's the frame rate? It's not bad, actually. Yes. Okay. Okay. So let's see what we can do. So probably the light isn't ideal here in this corner, but probably also not too bad. We have the top light, so at least we have some light there. Call it butt cam because it's behind you. That's a good one. That's a good one. So let's figure out if we can do it. First of all, I need to find against the where's heat certs to go. Here we go. This is one. So what can you see? Well, you can see it. I'm not sure if the camera is able to focus on this. How close can we get without, I think that is too close. It probably doesn't focus, it has no autofocus, completely fixed lens. It's not sharp. So you see it is not, it's not able to focus anywhere. Like you can hold your hand in front, but it's not focusing. So we can, I mean, if it is good enough, it's good enough. So let's do the first one. And you see what you need to see. One question for me is, how far do we need to push the heat sets in? It's not really mentioning that. So the holes for the heat sets are pretty deep, but yeah, I mean, I wouldn't push it too much in. I would just leave it so it's touching. It's just below the surface, not so much more. And yeah, we're already touching this part here. Sure if this is intentional. So close. Let's see if we need to sand this off. It was very much close to the hot iron. I'm not sure. Is this really good? We're very, very close to this. The diameter of the soldering iron is probably pretty standard, so it's not, shouldn't be an issue in my opinion. If that would be an issue, if it's too thick and it starts touching the plastic, well, I think then we have a design issue. So far, I think we can make it. Is it good enough? Deep enough? Oh, come on. So that should be good. Only part is we touched this plastic here. It might be that we have to, maybe we created a little bit of a problem here, but now it's also, I removed it. It's probably good. But again, I mean, we can't get more, like we have no space here actually to work with the soldering iron. If that is a design problem, then it's how it is, right? We cannot change that. Let's see. Okay, we have 3 done. We have another one in, how's it called? The shuttle. What is the shuttle? Where's my shuttle part? This is the very small part here. That's the shuttle. And getting the heatset insert in here, a little bit more tricky. Don't want to touch my hand with the soldering iron, but I can do it. I can do it. Good. It's done. And last but not least, part number 3 is the mid body. The mid body part requires us 3 heat inserts. So this one is obvious. And then we have another one over here. The last one is, again, it's in this sunken area. Hope we're not touching it with the soldering iron. The rest doesn't seem so, at least. Okay, maybe a little more. Okay, that's great. Should be done. So from that perspective, I think we're good regarding the heatset inserts. Let's figure out how the whole thing is assembled together. In that instruction, we also have to do an M2 screw, which is an M2 2.6, 2 times 6. That's probably also in one of these smaller bags here. Is it? No. No, interesting enough, not. I had the impression that this bag specifically was for the tool head, but it's not only. So then there's probably more screws here with one M2 by 6, M2 by 8. No, very close, very close. M2 6. And how many do we have left? We have 5. Okay, that should be good. So let's see. We need one M2 6. That is, where is it going? Oh, here's a little hole. It's supposed to go in here. There's no heat insert for that. It's just going into the plastic. Let's try. Can we actually reach it? Yes, it's just the angle is just working. Good enough. Okay, how far? This M2 screw threads into the plastic of the mid body part. It will be used to adjust the meshing of the BMG gears at a later step. Threading it all the way in at this step will make it easier to access later on. Okay, we're threading it all the way in then. Okay, so it's all the way in. We did it. What's next? We also have to do some more thread inserts at the bottom of this part, which we missed. How many? 2? Okay, there's 2 more. I think, but that's it about thread inserts. I think that's it. Not more than that. So let's do the missing 2. Probably want to do a button for my camera now. Let's add another button, so I can reach it from my Steam Deck. Here we go. Okay, let's push the button. Does it work? Yes. Okay. Problem with this whole heatset workstation is we need to make sure that we're not overheating the whole thing. If it's getting too hot, the mount is going to melt. So I want to reprint this whole mount. Looking good. Yes. The whole mount is PETG, so it's not the best material. Not the best for temperature resistance. So I would probably do this one more time at some point in the future. I'm gonna reprint this thing. But not today. Not today. Okay, so let's wait, heat it up. Okay, great. And we're pushing in. Is it all the way in? Yeah. Good. Next one. So this is difficult. It's a little more difficult to align it so it's vertical, but it is doable. Nothing protruding. Okay. These are hopefully the last two to do. Okay, that's finished. Now it is up for us to mount a BMG idler. Let's figure this out. BMG kit is basically just a complete LDO kit from Bondtech. All of the parts that are required should be in here. So we have this idler here. And we have these two little bearings. A lubrication film is required to ensure smooth operation and longevity. Refer to the sourcing guide for lubrication options. I would say we can just use our typical, the same grease as we used for the linear rails. That's my assumption. So lithium spray. And how is it working? It's going to be inserted here. It's going to be coming together like this. We have this. Is it working, my friend? What are you doing? Here we go. These are the little bearings here. And that's at the end, it's going to be pushed in here. So we should put some lithium spray on. That's it. I think that's good enough. Not too much. Don't want to overdo this. Next up, yeah, we're pushing this together, basically just pushing in the bearing into this idler, just simply in the middle. And then we have the support part removed. That's one of the little things here. And you see this is the part where this is all inserted. So we're using this, and the idler just goes in, clicks into place. That's how it looks like. Come on, focus. Here we go. Little idler. Good. Then we have another screw. It's an M2x10. That's used for, it has no like mechanical function other than strengthening this part, if I'm not wrong. So how is it inserted? It's going to be inserted in this little hole here. So we have a little screw goes in, and that's just there for strengthening this whole plastic part. So it's just enforcing, or it's in just, I was adding another, yeah, like a little metal rod into this part. That's just making it a little bit stronger, supposedly. So it's just in there, so making this part less likely to break. So exactly here, there's going to be a lot of force against this plastic part, and I think they are using this to make it less likely to break, exactly like here. Makes sense to me. Okay. So check the orientation. We did the self-tapping screw. We did lubricate the bearings. This is good. Then we have the gear. Short end of the shaft. Check the short end of the shaft. If it's longer than 3 millimeters, shorten it to under 3 millimeter. The design for a printed jig that can be used to help sand down the shaft is included in the released files. I'm wondering, is this the, no, this is a 5mm jig. Is this the 3mm? We have this helper tool here, which is the Swiss Army knife for building the Voron. And I think it is going to be this place where we have the 3mm. Let me check if that's true. It's 3.2. Is it good? Probably 3.5. Can that be? Probably not the. It's probably not the one that I want to be using. Maybe we need. I mean, we can just do it with the caliper. So they tell us that this end here shouldn't be longer than 3mm. So it's probably not that easy to measure. Let me figure out if I can. Can I do this? We can probably just first measure out this length here. How much is that? That's 3mm. And how much is it together? Or let's see, let's use this one here. It's 7 point. Yeah, it's 7. So it should be 10 together, right? Shouldn't it? $9.5. So the middle part is 7, and with the shaft we have, yeah, it's not easy to reach it, but it's under 3. I think that was the condition. Under 3. So we are under 3. That's good. Okay, so this part is good enough. Then we have 2 little bearings that come in the kit. One goes to this side. Tiny, tiny bearing. And we're also checking the bearing fit on this side. We also have to remove it because before we are finally pushing it over, we need the gear to go on, the drive gear. Just need to check which orientation we want to have. Yeah, we have this printed jig. I think we don't need that, honestly. So we move the bearings from the shaft after checking the fit. I think we're good. The fit is fine. They work fine. So what next? Printhead component preparation. So we're pushing one of the bearings in, and that's and we need an M3 hex nut as well. So let's first make sure we have the M3 hex nut. Here we have them. And we want to push in the bearing as well into this part. Super glue this hex nut. It is critical that this hex nut not come out of this printed part. Adding a small dab of CA glue will help it stay in place. Be sure not to get glue on the threads. That's always the most difficult, almost the difficult part. So let's get the glue out. I hope I have enough super glue left. Here, this is already pretty much used up. I will start just by having a little bit of a super glue here in this place where we're going to put the hex nut in. Just a very, very tiny bit in this corner. Very careful. Yeah. I guess we don't need more than that. And now we are pushing that in. Oh, why is this magnetic? Okay. It's done. So we glued the hex nut in. Now we have the bearing. We also need to push that in. Come on, that's the flat side of this tool. Let's maybe use this flat just to make it flush. Okay, great. So the bearing, where am I? Here we go. The bearing is in place. The hex nut is glued in place. Now up to the next thing. Do not apply glue to the bearing. Obviously not, yes. Now the printhead also will get one of the bearings, the counterpart basically. And what else? The shuttle will be in place, the guidler, the latch. Not yet anything else in terms of screws. So we just need to make sure that we insert this bearing in the correct position. So let's push that down here. That is a little more challenging. Let's use this tool here. Okay, the bearing is pushed in. It's also nicely sitting in there. So what are the next parts? We have the shuttle that goes in right here. Can we zoom in a bit more? Yes. Is my lamp empty? Seems that I need to charge it. But lucky we have more. Come on. So we have additional bit more light here. So that is the shuttle. Next is the guidler. Orientation this way. Okay, that's the guidler, as it's called. And then we have the latch. The latch. Where is the latch? This is the latch. Okay. So, I'm interested in the end how this is all working together. So, these parts are at least in position now. I'm wondering, the next part is the mid body. Mid body orientation, again, I think it's this way. I'm going to push that down. Mid body, okay. I love it how nicely these parts fit together, honestly. This is, the material is it has so little warping, if any. Things are coming together really nicely. So now we need screws. M3 by 25 millimeters. M3 by 25. M3 30, 35, 25. Here we go. 3 screws go in. And where are they going in? Here. Okay, 1, 2. 1, 2, 3, like this. So find the right screwdriver. Okay. So we want to attach it now. The lower M325 screw acts as a hinge pin for the guider arm. Be sure not to over tighten it. Okay, this is the one. So we don't want to over tighten this where this guider arm is hinged on. Let's start tightening it a little bit. It should be moving freely, but the screw should be in so we can feel, okay, it's touching, but this part is still moving. The rest can be tightened more, seems. Nice. Okay. Again, don't want to overdo the screws. Then we need M3x10 screws for M310. Also the bullet head. Where is it? Here we go. Two pieces. Where are we doing this? From this side? Yes. From this side. Interesting. Is there a counterpart for this? I forgot. Is there any? Yeah, I think we did threaded inserts there, right? Did we? Not sure. Yeah, I guess there must be, the threaded inserts must be there. Exactly here. It's not grabbing. Part wasn't fully pushed in. And it works. So that's why you need a ball head screwdriver, because otherwise you would be using this L-shaped hex wrench, and that's tedious, honestly. Okay. What's next? We have to finalize this part here, which is the drive gear. Check the orientation, yes. But I'm also seeing that we don't have the grub screws in there yet. We need these little tiny grub screws. We need to make them, we need to insert them first, because they are not yet in this drive gear. It's super, super tiny. So first need to find the right screwdriver for this. Is this the one? Yes, it's a 1.5 millimeter. So I think the first thing here we need to prepare this. We have the little guy here. This goes in. I'll get it in place, but not too much, so we can still push this over. Yeah, that was already too much. Now we can push it over, and the question of the question is, how far should we push it over? Is there some kind of we will finalize the gear's exact position on the shaft in the next step. So we are not yet there, like we can just fix it now a little bit at least, so it is not moving anymore. But we will definitely find the perfect position later. I think the alignment of this filament path needs to be done later, so we have it exactly in the perfect position. Okay, just ideally it would go in here, right here, right? Yes, and it's running against the idler, and looking into that little hole here where the filament path is, we have to alignment. We have to do the alignment later. So not sure if we are supposed to push that in yet. Let's see. check the orientation. Yeah, we will definitely do this. We'll push it in. We'll keep it there, and then we're also closing this now. Interesting. Is this working? Or is it? No, this is the right one. It's the right orientation. This is how it comes together. Okay, and here's where the motor will touch the gear, right underneath here. Now we need 3 more fastening screws. Which ones do we need? M3x6. Okay, let's figure out if we have those. Is this in the kit? M312, M38, M38, M36. Here we go. We need 3. So we're gonna fix it in place. 1, 2, 3 screws for this. Oh, one is going down in a little bit of a cavity here. It's just supposed to be like this. What was the question? Hey, Tudum Carmen. Hey, the guy made it. Welcome. Welcome tonight. Happy that you're joining us tonight. It's late. Why is it? No, it's not. It's not holding. There's one longer screw. Okay, I missed that. There's M3x10. This is one. I was just wondering why it's not reaching the threaded insert, but it's just too short. Okay, let's find M3x10. So many different screws. Okay, so for Furious was working fitting a massive CCTV system. No, I didn't do a new battery for the caliper. I think I looked for the batteries. I didn't find the matching batteries, so I had ordered them from Amazon. So, is this working? This looks already quite decent. Wondering, why is this so? Is this supposed to be movable? Did we do it too tight? Is it too tight? Should this be moving? Not sure. The latch, I'm wondering, is this latch supposed to be moving freely? Honestly, I have no idea. No, I think not. I'm not sure. There wasn't anything mentioned about that. So my best guess is this is not supposed to move, but I can only guess. Maybe this is, I'm not sure, it's not moving. Theoretically, it should be movable. Is it wrong, maybe? Or is it just the counter element for the gear? I'm not sure. I'm not sure why it should be moving, actually, honestly. It shouldn't. This is the only part that should be moving. Maybe this is just fixed in place. We'll find out. Good. M3x6. So we did attach this part here. We attached it here. Yeah, I think it's just a counterpart, you're right. The printer that I've been using to print all of the parts is the Creality K1C. So all of the parts for the Voron have been printed on a K1C. And they are all printed with ABS X from Nobufil. It's a great material, it doesn't warp. Theoretically can be printed without an enclosure if you are just printing small parts. But I love the colors and it's really working well. So I think we are done with this piece. What should we do now? 50 gears for the gear spacing. How should we do the gear spacing? For the next steps, we need to ensure that the 50th gear is not rubbing on any of the plastic part. It should be generally centered in its available space between the mid-body and the motor plate, as shown below. Make sure your guidler door is open so that you can freely adjust the position of the 50T. How can I adjust? The guidler door is open. How am I supposed to do this? Okay, I'm beginning to understand how this works. So we can yeah, it's interesting. So I believe at least how it works is in this middle section here. It's very, very hard to see right now. We have this, the gears are fixed on the shaft and the shaft also holds this plastic gear. Now there is a little bit of space here still. And we cannot move it out a little bit more. So it's probably not perfectly centered at the moment. It's not perfectly centered in this slot here. To move it or to have it, give it a little more freedom to the right, we need to release, we need to unscrew or release that little grub screw here. And now we can actually move this a little bit out. All right. Get my finger in between here. Come on. We should now be able to, oh, come on, it's so thin. So now it looks much better. It's a little more centered. Theoretically, we could now tighten that screw again. So by moving this gear on the shaft just a little bit, we gave it a little more freedom. So it's now more centered in this little slot here. That's where it should be. So I should not have contact on either side, not on this side and also not on this other side. It should be moving freely, and that's what it's currently doing. Looks good. I hope that this is actually the thing that we need to do. This idler here actually moves completely free. Now what I'm wondering also, there is the idler for the filament gears that is completely free to move left and right. And there's also no grub screw hole, if I'm not wrong. There's no grub screw hole that would hold it in place. So I think that's good. let's see what the manual says. So we did align this. We are adjusting the position. We did that. Now align the drive gear. While the 50-threaded gear is centered, open the guide lever and loosen the grub screws on the BMG drive gear with the small Allen key, then adjust its position left to right so that the filament path is aligned with the gear teeth. Hold the 50T in position while adjusting the drive gear so it's still centered on its gap. Once happy, tighten the grub screw. So yeah, let's try that. The alignment is now good. I can insert some filament now, and then we try to align this as best as we can. Let's find some sample piece. Yeah, let's use this. Okay. So what are we supposed to do? We're inserting some filament. We want to make it straight, hopefully. As straight as possible. Now, come on. So, pushing the filament through here. Also to the bottom. So filament is in. Now I need a bit more light. And I need to see the filament and where it is relatively to the idler or the drive. Now I can try to push this into, just push it a little bit so it's better centered. I think it's already pretty good, but we can probably move it just a tiny bit. So it seems to be centered. Now we're still good with the teeth. Yeah, we're still in the middle. And this is also better aligned to the filament. So it seems to be centered now. And for me, it feels like filament is, the grip is good. We are transporting the filament through. What? Don't fall. So let's have a last check. Is it good? Is it centered? Yeah, it looks centered. For me, that looks great. Let's try to show it. Sure, is it possible to see? Where is the filament path? Here we go. It's not easy to see, I agree, but you see, that's what we had to do. We had to align the filament path and the drive gear so they are in line, and that's good. Looks great. Good, good, good. Now, last step in this section. We aligned this. Our 50T gear is nicely aligned as well. Is it? Or did it move? No, it's okay. It's actually perfectly aligned. So we aligned this. We still made sure that we are in the middle. Note, then we have this spring. That is a piece that's already prepared. And that spring is pushing the guidler. Okay, so now the spring is in place, and as soon as we have filament in, we can test it out and see, is it transporting? Yeah, and it's pushing. And how much pressure we need, we can figure that out. Just we don't want too much pressure. That's great. What next? That's interesting. You cannot check that anymore, honestly. But I'm sure we did the right thing. I think we did it right. Mad scientist! Hey, you're late, but still welcome to the screen. Thanks for coming. Currently have 8 people on Twitch watching. It's awesome. 0 people on YouTube. I think everyone made it over to Twitch now so far. That had worked so far. Tweet. What's tweet? Okay. Okay. Great, great, great stuff. Where's my guide now? Where did I put it? Oh my goodness. YouTube, Voron, here we go. Let's shuttle. The printhead. Anti-squish thingy, what? Anti-squish thingy magic. Softer and flexible materials will deform and extrude poorly under too much tension. Mini stealth burner adds an anti-squish thingy magic screw that sets the minimum distance between the drive gear and the idler. Backing this screw out increases this distance, and tightening the screw in decreases this distance. Setting this minimum distance to prevent the gears from meshing too tightly or binding up in the extruder. Okay, this is probably something we want to do later. Not sure what is the right tension at the moment. So, close the latch and put a piece of filament through the extruder, and then spin the 50T with your finger to test the feeding capability. If you're looking for light teeth marks on the surface on the filament, we will repeat this step once more after the motor is installed. I did that. Didn't check for markings, but I think butt cam. The press cam needs to be called butt cam. Oh my goodness. So, printhead fans. Now we're getting to the blower fan installation. 1 and probably we need 3. We need 3 fans. Okay, let's do this. First of all, we need the bag, which contains all of these little fans. Okay. Now, some of them are different. These are the blower fans. I think these are the axial fans, and these are the blower fans. So let's find out how to orient them. This is how it looks like on the drawing. This is where it's supposed to point. Well, let me see. One of them is going in here. So we want them to face outwards, and we want them to be pushed in here. I'm not sure. I think they are not actually using screws to fix them in place, right? So just pushing them in. So removal is easy. Then the second one is the front fan. That is supposed to push air in. That means also from a cable. There's a little cable guide, if I'm not wrong. So we want to orient this fan so that it pushes the air in, and we have the cable going here. Where's the hole? Yeah. So fan sits right here in this little hole. This is how it looks from the front. But the cable is supposed to be going in this little slot here. Suppose that we have to turn it by 90 degrees. Otherwise we cannot do this. So now it should be working. So we can now push the cable right in here. Okay, that's where the cable should go. And now we finally push this blower fan in. It's also pointing, this is pointing out and down. Interesting. Where is this cable going? It's going up. It's going into the same little slot. So we need to make sure that we have both cables in this slot. It seems to be working, but I can't. It's not enough space, is it? Yes, it works. Okay, so now everything is in place. We have the two blower fans cooling the parts, and we have that front fan that is cooling the hot end, the hot end, upper end of the hot end. Good. Needs a 10-inch screen. The tiny fans. How big are the fans? These are, what's written on it? Oh, it's so tiny. Even the writing is so tiny. I need glasses, honestly. So is it written on there? It's a 3010 fan. 3010. Okay, so next part here. We are attaching the pancake stepper motor. Let's take it out of the motor box here. We need two with an M3x10. M310, are you sure? Yes. Okay, design with intent, screw hole is a little bit slotted, okay. And we are using the long screws, we're not tightening them up so much. Seems so. Oh my goodness. Open up the extruder latch and drop the guider down so you can freely rotate the gear. And that was exactly my question. Why shouldn't this be movable? Open the extruder latch. Is it possible? Yes. Okay, it's just very tight. It's supposed to be, probably. Okay. Okay, great. I get it. I get it. It's possible. It's just not. It's probably not supposed to be moving so easily. So let's have the motor fixed in place first. M3x10 is the screw size that we need. we're starting with 1. Interesting enough, doesn't mention the second one. Where's the cable supposed to face? Probably, is it facing up? Interesting. Why is it facing up? Is it facing up because of the... That is, we should double check in the manual where this is supposed to be facing. I think this is one of the steps where maybe because we have a different cable system. Okay, skip 186. 186. Are we yet on 186? No. So as we reach 186, we need to be careful. But realigning the motor direction is also not the biggest problem. But I guess they mean that we want to face the cable. We want to face the cables upwards, which I'm fine for now. So we're inserting two times the M3x10 screws as one of the next steps. Actually, this isn't the easiest thing to do because there is not much space for the screwdriver. I think we've figured it out. So we're not pushing too much. Not yet, at least. Let's do the other side. So the idea is probably that the motor being a little bit movable up and down, the amount of pressure against this gear is adjustable. So we push it down a lot. It's probably touching now. And we want to be able to adjust how strong we want to have the motor pushing against the gear. I'm not sure this is going to be like perfectly aligned. Let's figure this out. That is the next step. So I'm still keeping it a little loose, so we can still do this kind of adjustment now. So geared up, we've kept it loose. We have one that has basically no play. That's this side. Can tighten that a little more. And we have this side, which is definitely has more freedom to move. Okay, so let's see what the manual says. So better get your bifocus. Yeah, I have my zoom glasses, so I have them. We are opening a latch and drop the guider down so you can freely rotate the 50 threads gear. On the next page, we will be setting a proper gear mesh between the motor tendency pinion and the BMG 50 thread gear. You will benefit from good lighting and some magnification, but it's not a requirement. Okay, so let's open this up first. I obviously need more light. So let me open this. We did open this guider, or this part. The latch is open. How can I now open this part? Can I pull it out a bit? Yes. Okay, I see how this is meant to be. So we are able now to open this and pull it back. See, okay. is really an interesting construction. So now we can move. What was the side we can move? Okay, this is the side where I can move. No, this is the side where I can move. Now it's already engaging. Can we see how much it's touching? Can we? Where's the place where I can see this now? Okay, I did pull it back, but I'm wondering, like, where can I see the gears? Just, this is not easy to say. Actually, where is it? Is it visible somewhere? Is there, am I just looking at the wrong thing? Okay, adjusting motor backlash. We need to adjust the amount of engagement between a motor pin and a 50 thread gear. With the latch and guidler open, hold the pin print head and at an angle that allows you to easily see and move the gear. Use your finger to manipulate the 50 threaded gear back and forth. As you do so, rotate the motor down into the gear. As the two gears begin to mesh, you will feel and see the play. You will see the play become less and less. Once you have a very small amount of movement, your gear meshing is set. Okay. I see. Probably they mean the gear, the amount of play that we have here. So it's already touching the motor. I can feel it. The motor is already turning. So I'm pushing it down a bit. Maybe we need to release this a bit more. So pushing the motor, I mean, yeah, there's definitely a difference. Still a little bit of play. And pushing it further, just a tiny bit. Still a little bit of play. Pushing further. It's getting less. But it's too loose. We have to tighten that a tad more. It's not moving so easily. So push that. Okay, that's too much. It's the minimum amount of play. It's just tiny. I'm not sure if I should push it further, honestly. There's very little play now. It's very, very little. But there is some small amount of movement. So it's very, very little. But you can still hear the clicking, but you can't barely see it anymore. There's no movement. Okay, let's tighten that up and try to move it. Carefully. Okay. Let's see if that is, and it's moving. It's, yeah, it's good. Very little play, I would say. We can still feel there is a little bit of play. Still hear a little bit of clicking, but it's not visible anymore. You can't see the movement anymore. I think it's good. Great. That is done, my friends. That is done. Every mini stealth burner I've seen has the cable facing downwards. I have no idea why in the picture they have the motor facing the cable upwards. It's very strange. But yeah, interesting. You see where the cables are in the manual. Cables are facing up. Let's see. So After tightening down these two screws, be sure to recheck that you still have proper gear meshing and yet you still get live teeth marks on the filament when it's fed through the extruder, so there are no surprises when the time comes to push plastic. Okay, let's do this. We're closing the latch. Okay. We are pushing some filament through. Oh my goodness, what did we do differently? I'm not sure. I'm not sure what you do differently. So this is very strange actually. So I pushed in this part. So now we should actually have contact. We should have contact with the filament now. Should we? Shouldn't we? But it's not touching. Distance is too much. Strange. Maybe. I'm not sure what I did wrong here. So this part is, I see. Okay, we have to move it and close the latch at the same time, and I guess. So now we should have contact, right? Yes, filament is going through now. Okay. That's where the latch, how the latch works. I didn't fully understand how the latch works, but now I get it. Okay. You have contact only when the latch is closed. Yeah, that's also my conclusion. Now, what now? Printhead. We are doing the Voron Revo. I'm excited, my friends. The Voron, the Revo Voron. Let's get this done. Still don't know about the spacers, what the spacers are supposed to be for. Yeah, but let's see. Okay, so we have the Revo hot end, E3D Revo hot end. This is a Revo hot end. This one we don't need. Here we go. Couple of pieces. This is the heater. This is the small. These are the tiny, the nozzles. And this is the hot end. Or the cooling block, basically. Oh my goodness. Yeah, we're getting there. We're getting there. We're getting there, and we're gonna build it. It's gonna be finished soon. So this is the piece holding the Revo part in place. We need to fix it with a couple of screws. And the way how the Revo hot end works, or the Revo system works, we have the cooling block, basically the upper thread cooler, and then you just push you just thread in the whole nozzle and the upper throat basically, and you can hot swap or cold swap the nozzle, but you don't have to cold or hot tighten it. So it's basically the whole upper throat and the lower nozzle is one piece, so it cannot also come apart, so there can never be a gap causing any clogging in that way. Of course there could be clogging happening inside here, but it's most of the time the clogging is caused by these two parts coming apart or just having a little bit of a gap. And it's just by removing the filament you can just get it out and do it with your hands. You also don't need to crank it like crazy, right? Because it is enough if you just hand tighten that and that's it. And then you just can unscrew it. Super, super easy. Now let's put it in place. I think it is symmetrical, so we don't need to figure out an orientation. We just need the right screws for fix it. M3x8, 4 pieces, and since this bag is probably exactly what we need, so let's get this done. We are fixing the Revo hot end in the mount. The Iron Man colors. Yes, I remember. You remember the discussion what we had when we did the color selection a couple of weeks back? We said, okay, this is going to be the Iron Man version. Absolutely. So that part is connected. Looks awesome. What next? We need a PTFE tube and measure the right length. PTFE tube is, yeah, we have a PTFE tube. How to do it? We push it in until we touch the upper end of the thread. We want 6 millimeters. The total length of your PTFE tube will be dependent on the hot end you choose. Regardless, the tube must be cut to a length which enables it to protrude from the top of the hot end mount by 6 millimeters. The other end of the tube should be captured by the hot end. When installed in the rest of the tool head, the tube should not have any extra room to move up or down. Okay. So we need to figure out that we want 6 millimeters protruding. It's an easy way to cut it into length. Yeah, there is this little tool here, which we did print. So this is, we put it on top. And now we should have 6 millimeters protruding. The Swiss Army jig. So put it down on the table. Get a sharp knife, cutter knife. I'm just gonna cut it. Let's use the scalpel. So let's cut it off right there. So we want this not to come out. And that's a clean cut. Good. Great. Great, great. Now we are mounting the hot and the extruder together. Yeah, we can already put the nozzle in. Just check it out which one is which size. Is this anywhere written? I have no idea. Cannot really fully remember what there was in this box. We have a 0.4 and a 0.6 millimeter nozzle. Honestly, is there any writing on here? Good question. I think we want to start with the 0.4. Is there anything written, or are they just color coding these nozzles? Here we go. We have underneath this little rubber, it's 0.6, so they have blue for 0.6, red for 0.4. So let's thread it in. See how that works? It's super easy now. We're done, right? So it's nothing else to do. No hot tightening, and it's going. Where is it going? It's facing, so we can read Revo. That's the moment where everything needs to fit. Also the blower fans. So pushing this up, so we have the PTFE needs to go up now, up and in. Maybe we don't want the nozzle to be threaded in yet. I'm a little afraid that I'm gonna bend it. So we need to push this in. I'm wondering, can we do it? Can we make this work? Maybe we wanna insert this first. And then we wanna push it over. I think that's my best guess here. That's maybe the better way to do it. Okay, so pieces are coming together. This is in place now. And now we need to fix it with M3 by 35 millimeter screws. M3 35. 2 screws from the front. Okay, it's not really holding it. Yeah, I know. Okay, it's pushing against our. That's clear. So it's pushing against our printer's gantry adapter. So yeah, I understand it now. So we have 3 mounting contact points, basically these 3 points, this hex nut here, and these 2 screws are going to hold everything on to the gantry slider. 1 screw is coming from the gantry slider, and these are going into the gantry slider. So yeah, then for the Voron part, we have the heater core. I'm not sure like which was I think this is the right orientation. So you are pushing basically you're putting the heater core over the nozzle, and then you thread it in, and then this spring is automatically pushing the heater core into the right position. Now it is sitting where it should sit, right? And that's how it looks like. Cables are, I don't know about the cables where we are going to route them, but here we are. And now we are fixing the printhead in place. That's how it works, right? So we're gonna put it on our gantry slider. One thing that I did not yet do, after we tightened the belts, we will definitely see that these the belts are still sticking out here. So probably, very likely, once we start putting this over, we need to cut the belts. We need to cut them, we need to clip them flush. I was hoping that we would have some, I don't know, some room that we could maybe have the belts a little bit. I'm not sure if we can keep them. I don't think so. Yeah. We might be able to keep a little bit of the belts protruding, but not that much. We can figure it out. I think there wasn't nothing. Was it really mentioned somewhere? Let me go back to the step where we did the belts. I'm not sure if we should cut them completely flush, because that would also mean you cannot tighten them anymore without. Yeah, we only have the chance to. We cannot do that anymore, right? If we ever had to tighten the belts and pull them out, we would have no chance. So I'm trying to figure out if there's any step in the manual saying, okay, you need to cut the belts to a length, a specific length, when they are out of this tensioning part. So belts are same length. Running the belts, blah, blah, blah. Interesting. Securing the belts. Once you have run each belt, you can thread the loose ends through the X carriage and begin to pull them tight. We blah blah blah. We pulled them tight. Do not trim the belts to final length yet. We will continue the belt tightening with the tension knobs after the part is mounted. Blah blah blah. Once the belt tensions are equal, which we did, trim the belts to their final length. The amount you can leave depends on the hot end you are using. If your hot end sits flush against the X carriage's front-facing surface, a flush cut may be required. So we have to figure out ourselves basically how much we need to cut the belts. If we need to cut the belts flush, we should definitely figure out, where is this step here? We definitely need to figure out, can we push the belts to the side? How much can we leave? Honestly, I don't want to cut the belts completely off. That would not be my preferred way to do it. But let's figure it out. I will try to push it over and see where these belts are actually located, if they are becoming a problem or something. I don't think so, actually, but maybe I'm also wrong. Is it completely flush? No. We could get away with not cutting the belts. Let's see. Let's see if this works. So I'm trying to fix this in position. Let me try this. And then let's see if we have any play. If we leave the belts and like they are and not cutting them. Just want to see. So I need more light, obviously. It's too dark. Just see any gap. Or is this blue? There we go. Where are the belts now? I think they're actually not touching this part. My concern is more that there is still a little gap between the whole thing and this gantry adapter. Not sure if this is intentional. I mean, there. Okay, for me, looks like we don't have to completely cut the belts. Seems that they're not even sticking out anywhere. However, the cable management will be interesting. You see all of these cables? Like, I'm wondering how we are running the cables so that they won't interfere with the whole gantry, right? We have this cable here, this cable, we have that cable here. So where are we running them? So they are not getting anywhere in our frame. Or in this belt path or whatever. Very curious where we are running them and how we are fixing them. So they're not moving. It's gonna be very interesting. Okay, let's see how this works. What torch do you mean? Spring goes in the heatsink side. Okay, so let's have a look. So we did push this over. We did mount it. We assembled this part. Now we also need another screw that holds, like gives us additional security from that side. So it's like safety for the printhead. It's not falling off. That's an additional M316 screw. So for sure, this is holding well. Again, I'm really curious how the wire management will work, so it's not interfering with the belts. Next up, we have the strain relief spacers. Okay, now I get it, why they are there, why they are needed. Hopefully didn't push them from the table. No. Okay. So we need to put them over, where do we put them? Over this motor screws here. Okay. That's a strain relief spacer number 1. Number 2. You want to tighten them up manually. Good. And then we have a counterpart that's coming from the back. Where is this part? Didn't see it actually. Hope I printed it. Strain relief, spacer, blah blah blah. Strain relief. Ah, that's for the cable. Okay, that's cable management. Strain relief. Okay, cable management. There are loops for zip ties on either side of the toolhead and strain relief section on the top. Okay. I think we need to be checking where we are. 186. We need to head over to the LDO picobellical setup. Okay, I get it. 186, I think, is already where we are. 186. I'm not even sure we need this part. I think that's probably why I did not print it. So let's go to the LDO picobellical. Picobellical mount. I'm not sure if we have that actually. Is this something that comes in this kit? Is it metal? I'm not sure. This is probably what I'm going to leave you. I'm going to leave you now. It's getting very late. But so far so good. We achieved some progress. We did. Actually, this starts to look very much like a Voron printer. Very likely, honestly, guys, very likely I'm going to stream on Friday. So I will announce that. So you can see whether the one that you have that changes color. The torch light, I have multiple different lights here. This is an Aperture MC. Aperture MC light that can change color. That's a small one, and these are ambit full lights, which are tube lights. They also can change color. Very useful to work and also film. And yeah, so far I am quite happy how far we got for today. Since we managed to assemble all of this, we attached it correctly, the gears are running nicely, and now we need to take a picture. But as I said, we're gonna probably come back on Friday, continuing to build the printer. Very likely I'm gonna be back on Friday. So let me take a picture now. Starting to look even better. Every single time we build something here, it starts to look better. So I'm sorry, blocking off. So that's my picture. Yeah, but it starts to look like a Voron. It really starts looking like a Voron. Great. So again, I'm going to announce next stream. I will tell you that Friday night is very likely. So we can make some progress, some even more progress on Friday. Doing the even more cable management with the picobellical PCBs and stuff. Ideally, when we've done that, we can attach couple of, we can probably try to attach the wires to the main board just temporarily, and also the power supply, so we can try to check the movements. As I said, I don't want to wait until the last second to check that, because for now we can check anything, right? We can just push the printer's head in any direction, but we cannot really test anything. And if we had to do this at the last moment, we could probably find out, or we would maybe find out that something is not working, or we did something, I don't know, we assembled something in the wrong way. Then it's very late, and yeah, let's see. Good. Let's come back on Friday. I'm gonna send you the announcement very soon, also in our Discord server. Wish you a good night. I'm quite tired now. Benchy, when the Benchy? I won't promise it yet. I won't promise. It will run with a Big Tree Tech Pico. Big Tree Tech Pico is the main board, and Raspberry Pi for the controller. So, see you next time. Bye-bye.